Let's make sure I'm not crazy. I want to show you how to be able to use this. It's not very hard. It's just some keystrokes that you're going to have to memorize if my computer will behave itself. Come on now. Don't be shy. It's twitching. It's always a good sign. Come on now. Help a brother out. There we go. Okay. I don't know why I got that. Oh, it's because I was putzing around on my grapher. Don't worry about that. Just pay attention to the home screen. Won't mess with the view. Well, let's do it. View. Show hide. Go away. Okay. So all I'm going to do is I'm going to show you where these things are at. So I want to do 5p2. So I'm going to go 5. Now this is kind of a pain in the butt. Well, let me show you where they're at first. I'm going to go to math. I'm going to go over here to prob. You see this prob? Because we use these in probability. So I can all I do is left click. And then there's this command, which is NPR. There's also NCR, and there's also a factorial. We'll talk about NCR here in a sec, but that factorial key can be really useful as well. I'll show you how to do that as well. All right? Excuse me. So second quit. What I need to do, the only pain in the butt here is the way in which you have to input it. So I'm going to go 5, math, over to prob, down to NPR, hit enter, hit 2, hit enter, and booyah. And I get 20, just like we said. Okay. Now let's say that for whatever reason I don't want to use the key, or I'm using something that's not truly NPR, but I want to use factorial. So I would just go 5, math, over prob. Now, don't you wish they had hotkeys? It'd be nice. If you guys know how to do hotkeys, let me know. And then I'm going to divide that by 5 minus 2 factorial, aka 3 factorial. And I'll go over here, and I'm going to go down here, and voila, and voila. Nothing to it. Okay? Now, these are called, let's go back over here. These are called permutations. That's what we just did. All right? Now, I'm going to kick over. Let's talk about combinations. Something floating on my tablet over here. All right? Combinations. Where are we at? Combinations. Combinations. A combination is simply the number of ways to select. All right, no order. No order. There's no order implied in this. So all we're doing is grabbing them. Select R things from a total of n. All right, so let's do exactly the same thing. I got 5 students, and I'm going to take 2. Let's take 2 to lunch. Take 2 to lunch. All right, now think about this. In this case, does order matter? Am I electing a president, a vice president, a front seat, back seat, something like that? Now that makes it a little tricky. Well, if I want to take 2 students to lunch and we're going to drive in my car, don't recommend it for liability issues, but one person wants shotgun, one person's in the back. Now they're ranked because student number 1 riding shotgun, student number 2 in the back is different than student number 2 riding shotgun and student number 1 in the back. But all I'm saying is, I'm going to take 2 students, we're going to go down to the overlook, and we're going to have lunch. So how do I do that? Well, again, think about this. What we're going to do is, what we do, okay, we got 1, 2, 3, 4, 5. Now again, let's say, just for giggles, that I take 3 and 5. Now just like before, what I'm going to do is, I don't care about the order in which the other 3 students get to go. So I'm going to divide out their order. But Ripley, you say. You said you didn't care about the order in which the ones that did go. That doesn't matter, right? Their order doesn't matter. You're absolutely correct. So watch how this works. First, I'm going to show you how to write it. We're going to do C, and this is your author's notation. You don't see this very often, and I certainly don't use it at all. This is the same thing as 5C2. All right, now, here we go. Same thing as before. I take 5 factorial. That is the number of ways to organize 5 people. If I want to take 5 students and put them against the wall, and I should probably not pound on my desk, put them against the wall and shoot them. Would never do that, but let's say that I did. Then there is 5 factorial ways to do that. Now, I'm going to, just like I did with permutations, I'm going to go 5 minus 2 factorial. That divides out any order in the students that didn't get to go. And then I'm going to do 2 factorial. Why 2 factorial? because it divides out the order of the students that get to go. So from before, we know this is 5 factorial over 3 factorial, 2 factorial, and I'm going to cheat a little bit here mathematically. I remembered that 5 factorial divided by 3 factorial is 20, so this is just 20 divided by 2 factorial, which is just 20 divided by 2 times 1, aka 10. There are 10 ways for me to select 2 students from a total of 5 and take them to lunch if order isn't implied. So easy, so clever, nothing to it. So let's come up with a general formula to make sure it works. We'll talk about some special cases, throw it in our calculator, and we'll be done. All right, so we're going to do NCR. Remember, excuse me, remember how before it was NPR? Well, that's just NCR. So it appears as though the formula for NCR is n factorial. Take the total number of ways you can organize n things, and then simply divide out the ones that don't get chosen. Divide out their order, because that certainly doesn't matter, and then divide out the order of the ones that did get chosen. And that's your formula, man. There's nothing to it. It's really simple. Now, think about this. You ready? All right, let's go. Let's go with 5 again. 5 seems to be a good number. It's like the Goldilocks of numbers when dealing with these guys, because it's big enough you can wrap your brains around it. How about this? 5 choose 0. How many ways are there to choose nothing from a total of 5? Well, what's your guess? Think about it. There's only one way to do it. Don't choose anything. Just like, can you see that 5 choose 5 is also going to be one way. That basically says how many ways is there to choose everybody from a group of 5 if order doesn't matter. It's only one way. Choose it all. Well, look what happens here. This is 5 factorial divided by 5 minus 0 factorial. 5 minus 0 factorial divided by 5 factorial. Right? Or excuse me, 5 factorial. Somebody popped me in the head. 0 factorial. Right? So we're not afraid of 0 factorial on the denominator because we know that it's 1. This is 5 factorial divided by 5 factorial times 0 factorial. Well, those cancel, become 1. 0 factorial is 1, and voila. Now look close here. Aren't we going to end up with exactly the same thing? Just in a little different order. 5 factorial, take n, and divide by 5 minus 5 factorial, which is 0 factorial, times 5 factorial. You end up with exactly the same thing by the commutative property of multiplication, which is 1. How about 5 choose 1? What's your guess on this? What do you think that 5 choose 1? How many ways are there to select one student from 5 if order doesn't matter? Well, it better be the same as permutation, right? It should be 5. Well, let's check. I could be lying. You never can tell. It's going to be 5 factorial divided by 5 minus 1 factorial times 1 factorial. Well, 5 minus 1 factorial is 4 factorial, so this is going to be 5 factorial divided by 4 factorial times 1 factorial. 1 factorial is just 1, and we know from prior experience that that's 5. Can you see why this is exactly the same thing? Think about it. How many ways are there to select 4 from 5? Well, isn't that exactly the same thing as saying how many ways is there to leave one student? Which, if you think about it, is identical to taking that one student. All right? Nothing to it. Let's go ahead, throw it in the calculator, make sure. You probably already saw this, so let's make sure that 5 choose 2 is indeed 10. So I go over here, I go down, I grab this guy. There's 5 in CR. Make sure it drives me nuts when you guys make errors around the P and the C, which does happen. Just pay attention to your details and make your life better. And voila. Nothing to it. All right. Now, you can also cheat, like I cheat all the time. I'm going to use second entry. Like if I want to go 5C3, let's see how many 5C3 is. Look at that. It's 10 again. How about 5? Whoops, clear. Sorry, let's go second entry. What do we say? 5C0? We said there should only be one way. Booyah. How about 5C4? So I go second entry. See how I'm just editing what I have? And if I want to change this, it's kind of like once you have one, I can change everything in it. Like what if I wanted to do, I don't know, 7C4? Well, 7C4, and look at, whoa, look at that. I saw 04. Let's see why that is. 7 C4 is 7 factorial divided by 7 minus 4 factorial times 4 factorial, which is 7 factorial over 3 factorial, 4 factorial. Let me show you how I do this one. I got to do these by hand because sometimes it's just faster to do them by hand. If I think of 7 factorial, this is 7 times 6 times 5 times 4 factorial, isn't it? 4 times 3 times 2 times 1. So that cancels with that, right? Now I've played with these long enough to know that 3 factorial is 3 times 2 times 1, which is affectionately known as 6, and there's a 6 sitting right there. It's kind of like a canceler's dream because you have to cancel everything. So I'm left with 7 times 5, aka 35. Nothing to it. That's it, you guys. Hopefully you've seen it before, and this is just a refresher, but if you haven't, you're sitting here looking at something that's kind of interesting to play with. Have a wonderful day. I'll see you tomorrow in class, and we'll start playing around with these. Bye-bye.